In this video, we're going to derive the law of exponential change. And so the way how it works is pretty much the rate at which a population grows at a certain point in time is directly proportional to the population at that time. And so the way we could represent that is by saying that the rate at which the population grows is directly proportional to the population. And so pretty much you could imagine as the population increases, the rate at which the population is increasing also increases, right? And so that's the whole idea of how exponential change works in populations. And so pretty much the whole idea of what we're going to do is we're just going to solve this differential equation. So how can we do that? Well, in this case, we're just pretty much using separation of variables. And so what we can do is we can group p with dp by dividing p to the other side and moving dt to the other side of the equation. So pretty much switching the place of p and dt. And so what we would get is, right, we would get 1 over p dp is equal to k dt. And now we're pretty much ready to integrate both sides of the equation. And so what we get is we pretty much integrate both sides of the equation. All right, so we're integrating our population from an initial value p0 to a final value p. And we're integrating our time from an initial time of 0 to a final time t, right? So now we can solve these integrals, and we know how to solve this integral. It's just going to be the natural log of the absolute value of p, right? And we know that the value of p is always going to be positive because a population is always positive, so we really don't need these absolute value signs. So I'll just get rid of those absolute value signs, and pretty much it's just going to be the natural log of p. And so this, remember, we're integrating this from p0 to p. So that's our limit, our bounds of integration. So we're solving a definite integral, so we're doing that. And this is equal to, right, this integral right here, which of course what we're going to get is, it's just going to be kt, right, kt, and we're integrating that from 0 to t. And we know that if what this is just going to be kt, so might as well just erase that and just call it kt, right? All right. Now, evaluating the left side of the equation, we know that this is just going to be the natural log of p minus the natural log of p0, right? And also, we know the rule for subtracting logarithms. This is going to be the natural log of p over p0, right? Which is equal to kt. And so remember, our whole goal is to solve for p, so we should raise e to the power of both sides of the equation to pretty much cancel out the e in the natural log. So we're left with p over p0 equals e to the kt. And multiplying p0 to the other side of the equation will leave us with p equals p0 times e to the kt. And so this right here is the law of exponential change, based on the idea that the rate at which a population grows at a certain point in time is directly proportional to the population at that time. We find that the population is modeled as an exponential function with pretty much the base is e. So that's pretty cool, isn't it? Right? That the fact that the base is e in this case. And so this right here is the whole idea of a population that is modeled due to exponential change. And that is pretty much it.